In this section, we will create a second application to explore how to use positioners to display a number of images in a prescribed arrangement. Positioner types, such as row, column, grid, and flow, will help us easily arrange our items. So let's get started. Create a new project, selecting Qt Quick Application and naming it Positioners, keeping everything else the same as before. We'll change the window size to 1200 by 800 and set the window title to Hello Positioners. Copy the same assets folder containing the images we used in section 1 into our Positioners project. Use the Add Existing Directory menu option and select the assets folder as before to add them to the CMake project. To save us from increased repetition, we can use a repeater to create our 10 images for us. But first, to make it easier for us to try out different positioners, let's create a reusable delegate. We'll create an image component with a text label at its center to show an image and its index. Start by creating a component and give it an ID of image delegate. Inside the component, declare an image item and give it an ID. We'll add a required integer property to ensure the index property is provided whenever this component is created. We will set the image source by using the Qt resolved URL method, surrounding the URL with backticks instead of single or double quotes. Template literals can contain placeholders, indicated by $ and curly brace syntax. In our case, we are passing the index required property to build the URL for each image we want to display. This ensures the component has all the information it needs to function properly. We will also set asynchronous to true for snappier UI performance. Add a text item inside the image so we can see which image is loaded and its position. Set the anchors at the parent center and give it a nice pixel size, e.g. 30. Set the color to white with a black outline for readability over the image. Bind the text property to the image's index property. Now add the repeater to create instances of the image delegate. Bind the repeater's model to 10, an integer array of length 10 with values from 0 to 9. This tells the repeater to create 10 instances of the delegate, which is the image delegate in this case. Note that the delegate property is a default property of a repeater, so delegates may be declared inside the repeater without explicitly binding to the delegate property. The repeater will visually reparent items it creates into the repeater's parent item, but still retains object ownership. The repeater, along with the general concepts of models, views, and delegates, and the use of required properties, will be covered in a separate course. The repeater will create 10 images, but we need to arrange them. This is where positioners come in. Let's take a look. Let's start by adding a row around the repeater and running the application. All the images are side by side, but as in the first section, they all remain their native size. This immediately demonstrates one limitation of not just row, but all positioner types. They only position items without managing their size. However, the size of items is considered when calculating the position of each subsequent item. Let's provide a consistent size for the images, 100 width and height. After making this adjustment and running the application, we can see 10 images arranged in a row, each sized accordingly, displayed side by side, with the text showing the index of each image. Before we continue looking at the other positioners, it's a great time to mention that all positioner types we're discussing in this section share common properties that we can begin exploring. First, all positioner types inherit from item, so they have all the usual properties such as position, X and Y, anchors, visibility, enabled, and more. They also add padding properties like left padding, right padding, top padding, bottom padding, and a general padding property if you want to set them all to the same value. Using the padding properties creates a gap between the positioner's edges and the items it manages. We also have a spacing property, which adds a uniform gap between each item horizontally, vertically, or both, depending on the positioner type. So how big are these positioners, such as the row we have here? Unless specified otherwise, positioners will grow to the size of the contained items, including any padding and spacing specified. We can see this in action by creating a background rectangle that follows the positioner's size. First, give the row an ID. such as positioner. Then, add a gray rectangle behind it and use anchors to fill the size of the positioner. Add a spacing value of 10 and see how this introduces a uniform gap between the images. Let's experiment with the spacing and padding properties a little more. Add a padding value of 10 and see how this adds padding around all 4 edges of the row. Now, we can see the total size of the row positioner, regardless of how many items it is managing or the values of its padding and spacing. Changing from a horizontal arrangement in a row to a vertical arrangement in a column is now trivial. Change the row to a column and observe how the arrangement shifts to a vertical layout. The spacing and padding are applied to the vertical layout exactly as expected, and the size of the positioner adjusts accordingly. Next, change the column element to a grid element and see how the arrangement changes to a grid. Grid arranges items from left to right and then top to bottom by default. The number of columns and rows can be set by the columns and rows properties, respectively. The number of columns defaults to 4 if we don't set the number of rows and columns, giving us our current layout. We can begin to understand how the default left to right, top to bottom arrangement works by modifying the number of columns. If we change the columns to 5 and then to 2, this demonstrates how the default left to right, top to bottom arrangement works. We can also constrain the number of rows instead of columns. Try removing the columns property and setting rows to 2. Now we get 2 rows of 5 images. In this case, the default column count of 4 is ignored because we specified a value for rows, making the column value dynamic. What happens when the grid isn't big enough? Why not try setting rows and columns to 2 to see what happens? You'll probably get a helpful output politely explaining the issue. Grid adds row spacing and column spacing to give fine-grained control over the spacing of rows and columns. The spacing property still works if either row spacing or column spacing is not specified. Play around with different values for the individual padding properties and spacing properties to see how they change the layout's visual appeal. For example, try setting row spacing to 25 and column spacing to 30. We've experimented with the number of columns to have the grid create a new row each time it reaches the last column. We've also seen how the order of the layout goes from left to right, top to bottom. If we want to modify the layout direction, Grid adds the layoutDirection property, which can be set to Qt.left to right, the default, or Qt right to left. We can set layout direction to Qt right to left and see how the order changes. The left to right order can also be reversed by setting the LayoutMirroring .enabled attached property to true. This is useful for UIs presented in languages like Arabic or Hebrew, which have a right to left reading direction. The effective layout direction is a read-only property indicating which direction the positioner is laying out the items. Row also has layout direction and effective layout direction properties, whereas column does not. For grid, we've seen that the arrangement order is row-based, populating rows from left to right or right to left before wrapping to the next row below. This is called the flow direction. If you prefer a column-based flow, where columns are populated from top to bottom before wrapping to the next column, Grid adds the flow property with the following values. Grid.left to right, the default, flows along rows in the effective layout direction, and Grid.top to bottom, which flows along columns in the top to bottom direction. Try setting the flow property to Grid.top to bottom and see how the images are now ordered from top to bottom in a column-first order. Coupled with layout direction or layout mirroring, you can arrange the images from top to bottom and right to left simultaneously. Note that you can't go from bottom to top. To achieve this, you must consider the delegate index usage and/or the model order. Also, the flow direction is not affected by layout mirroring, so there isn't an effective flow property. Experiment with Grid using your own content and try arranging items of different sizes to understand how Grid handles irregularly sized items. Flow is very much like Grid in that it arranges the items it manages in a left to right or right to left order, either by rows first or columns first using similar properties as Grid. As with Grid, Flow also supports layout mirroring and has a read-only effective layout direction that works in the same way. So, how is Flow different from Grid? Rather than specifying the number of rows and columns and allowing the size of the positioner to potentially change around our content, Flow's constraints come from its own size. Think of it like how word wrapping works in a width-constrained text box. If the word won't fit at the end of a line, a new line is started. Flow works similarly with the items it manages. Let's try this out. Starting with our initial row positioner, change it to Flow. Spacing and padding are supported as per all positioners, but since Flow doesn't have the concept of separate rows and columns, it doesn't offer separate row spacing or column spacing. Constrain the size of the flow to the size of its parent by setting anchors.fill. Run the app to see the Flow positioner in action. As we change the window size, Flow repositions the items, creating new rows as needed. Next, set the layout direction to Qt right to left and the flow to flow top to bottom. Note that, similar to grid, the flow property enumerations are qualified using the flow type, not the Qt type. Changing the window's height makes Flow rearrange the items so that new columns instead of rows are created as needed, in this case from right to left. Experiment with Flow using your own content, and try arranging items of different sizes to understand how Flow handles item arrangement and to appreciate how it behaves differently from grid. Positioners also provide 3 convenient attached properties: index, isFirstItem, and isLastItem. These attached properties are only applied to the items that the positioners are directly positioning. To access the attached properties from within the child items of those items, we must qualify the attached property using the ID of the repeater delegate. We can easily demonstrate how to use these properties by adding a colored border around the first and last images. Let's add a rectangle that fills the image and set its color to transparent and set the border width to 5. If the image is the first item, set the border color to green. If it is the last item, set the color to red. Otherwise, set it to transparent. We can also use the positioner.index instead of the model index in the text by changing it to text, image, positioner.index. Now we can see that the first and last images have a green and red border. Note how we qualified the positioner attached object with the ID of the image to access it. Also, note that depending on your setup or Qt version, QML may not provide code completion for attached properties when used in this way. Let's review some pros and cons of positioners. Positioners allow you to arrange items in a row, column, grid, or flow without having to reference the ID of any neighboring item. They provide additional functionality through the positioner and layout mirroring attached properties. Transitions, which we have not covered here, can be used to add basic animations when items change their position or are added and removed from the positioner. Spacing and padding offer a good amount of control over the arrangement. Additionally, positioners can be nested. However, there are some cons. Positioners only position items. They do not size each item under their control. The position of the item is always relative to the top left, meaning there are no vertical or horizontal alignment options. We must set the size of each item manually. Positioners don't make any assumptions about size and can't perform vertical or horizontal distribution. Nesting positioners may make it difficult to track the overall size of the positioner group.